This for my friend Abitu, because she's just such a curious student and she's so curious about physics. She asked about magnetic flux. So I thought I'd make a quick lesson video on magnetic flux. I'm going to keep it short because it's kind of a simple concept. It's really, so the definition of magnetic flux, don't make sure the L is in, when you're saying it, make sure there's an L in there. The definition of magnetic flux is, it's really the amount of, so here, I'll say it verbally, amount of magnetic field lines passing through an area, like an area by a loop or whatever. And that, let me visually show that to you. If you had, let's say, this loop of wire, right? And if you were to place it like on top of like a magnetic field, there's going to be field lines passing through that loop. There's obviously going to be some field lines, also outside that loop, but we're worried about what field lines are passing through the loop. So the question becomes, well, how can I change, how can I make my magnetic flux through this loop bigger? What do you think I would have to do? One option could be strengthening the magnetic field, right? So, I can strengthen that magnetic field, and there's more, that's really just more field lines, right? When I make the magnetic field bigger. How else can I change the amount of field lines going through that loop? Well, I could just make the loop bigger, so I can make it larger. And, if I make this loop a little bit larger, I just erased all those amazing field lines, but you could imagine it's going to be able to just capture more field lines, and it's going to be a whole lot of magnetic flux. The variable for magnetic flux is phi, okay? The equation, I was talking about area and magnetic field. Magnetic flux ends up being the product of the magnetic field times the area of whatever the magnetic field is passing through. So magnetic flux is actually a dot product. And if you don't know what that is, you should learn about vectors because they're sick. But a dot product, it's the same thing as work, where force times distance times cosine theta. If I make my theta 0, I get to maximize the amount of work that the force is doing. If I make it 90, I get no work done on that object, right? It's the same thing. If I had my magnetic field, you can imagine, hey, if I put my loop like so, I'm going to get a whole lot of flux. If I do it like this, no field lines are passing through. I am minimizing my magnetic flux. Now, you might be tempted to be like, okay, well, the angle between the field lines and the loop is 90. What trigonometric function, right? Because maybe I'm explaining this wrong. Maybe it's sine theta. This is what I'm trying to say. Maybe it's sine theta, right? Because, well, the angle between here is 90. And when theta is 90 degrees, by trigonometry, this is equal to 1. So, and then when this is 0, right, the angle between, it's 0, they're both parallel, then sine theta is 0, right, because sine 0, 0, this becomes 0. But you're not looking at the angle between, the magnetic field and the area, like the plane per se. This is a dot product, and you can only do dot products on vectors. Area is a vector, and the direction of area is like this. It's almost like which way it's kind of like I don't really know how to really describe it. It's just that way. Like, that's the way the area is directed, I guess. I don't know. So then if you think about it, well, now, hey, the angle between it is 0. when it's cosine 0, that's when you get 1, right? When you have cosine 0 degrees, cosine 0 radians, it's equal to 1. So the actual equation is BA cosine theta. So the angle does matter, right? If I slant this, right, around like so, hey, I'm not getting as much flux. Because if I were to reorient it, it would just have more flux. There'd be more field lines passing through. It all boils down to the idea of field lines passing through your area of loop or whatever. So that's magnetic flux. Hopefully that makes sense. Abitu, hopefully your curiosities have been cured. I don't really know the word. Hopefully you've learned something from this. Thank you guys for watching.